server. So really looking forward to this webinar, Allison.
Great, thank you. So chances are, if you're joining us today, you are interested in moving to data-driven manufacturing, and you may be in various spots along this journey, but we believe there are 4 steps that you need to take. First is connecting all of your OT assets, whether they be modern or legacy, making sure that you connect to all of those machines and systems. Second is collecting the data and structuring it into a format that is usable for other applications. Third is successfully sharing that data with those applications, both OT, IT, cloud applications. And fourth is really the key, is putting that data to work. That might mean feeding machine learning models in the cloud or running applications at the edge, but you want to be able to use that data to improve operations. And so today, the question we're trying to help you answer is, what is the right foundation? What technology do you need on the factory floor to enable data-driven manufacturing this year? And we're going to talk about whether that's an OPC server or an industrial IoT platform. Let's take a high-level look at OPC servers versus IoT platforms first. Dave, can you get us started with OPC?
Sure, thanks, Allison. So an OPC server is basically running on the factory floor, connected to different PLCs and different assets that are on the factory floor, collecting that data and exposing that data to other applications, analytics or machine learning. So different products that are out there. Mark?
Yeah, thanks, Dave. So an IIoT platform, very similar from a data acquisition standpoint to an OPC server. It connects to your assets, does your data collection, allows access to that data that's been retrieved, but then it really starts to build the next gen features for your data-driven operations. So your analytics, your applications, and the overall management of how you deploy and maintain the platform is kind of what starts to set it apart. And we'll get into some more of those details throughout the webinar.
Great, thanks guys. So let's take a little bit closer look at how each of these technologies works under the hood. Dave, we'll start with OPC server.
Great, thanks, Allison. So basically, OPCs are really only focused on the data acquisition standpoint. You probably, everyone here is familiar with the technology. It was developed in the 90s, hasn't changed a whole lot from the architecture from that standpoint. But basically, the whole process is it's connecting to each device. It's a multi-step process to get that connection made, and then handles that basic data collection. It uses OPC DA to expose that factory data to OPC clients, such as SCADA and MES and historians. It was really purpose-built back in the 90s for that data acquisition, not really designed to be changed often. It's one of those things you set one time and usually don't change it. And then the user interface, it's starting to show its age a little bit and how it's used. It's kind of an older look to that and something that people are not used to nowadays. Mark?
Thanks, Dave. And just want to mention that OPC servers are really only focused on data acquisition, right? And
correct.
Correct. Okay. So Mark is going to dive a little bit deeper into how an industrial IoT platform works.
Yeah, great. Thanks, Allison. So IoT platforms go beyond that data acquisition layer. So again, the main thing of an IoT platform is data acquisition. That's the first and foremost thing, but it goes beyond that, and it uses a lot more modern technology and security standards. So specifically, when you connect to your devices, it's more of a plug and play type connection and data collection. It gives you the processing and storage built in. So as the data comes in, you can do processing on it. You can store it locally right out of the box. It gives you the edge computing power, meaning you can run custom applications at the edge. You can do data management at the edge. And then it integrates a lot more seamlessly with your cloud systems. So specifically, the integrations can send data northbound, but then it can also receive data from your cloud systems or your external systems and start to work on your closed loop processing. So you can start to send data back into the shop floor environment. On top of that, it really gives you the flexibility and the scale, like to drive the scale that you're going to need in today's more modern data-driven operations.
Thanks for that explanation, Mark. So as we really get into comparing OPC servers and industrial IoT platforms, these are the capabilities that we're going to look at a little closer. On the top section here, you'll see we're going to focus on data acquisition, of course, which is where these two technologies really appear to be neck and neck. We'll talk about where they differ in those areas. Then we'll look at edge computing functions and management capabilities, which is really where you'll see these two technologies diverge. So let's jump into that. First, let's talk about how OPC server handles connecting devices. Dave?
Sure, thanks, Allison. So when we're talking about OPC servers connecting devices, basically there's multiple steps involved. It has to run on a Windows system. You install the server, then you go get the drivers that you need. You install those drivers, multiple licenses, multiple installations to handle all that. The interface is, as you can tell, if you've ever set one up, it's got kind of an older legacy Windows-based interface. It connects to devices using a Windows configuration wizard. So if you're old enough to remember the wizards back in the 90s, still using those today. And really an important part, I think, is it's still based on DCOM, which is a Windows proprietary software platform or object model. Sorry about that. That was built, I think, for Windows 3.1. So belated happy birthday to that. So kind of older technology, still works. I see that OPC and it's still used very much today, but is based on very old technology. Mark?
Yeah, thanks. So yeah, you're right. There is a large footprint of OPC server, but there is some differences with the IoT platforms. Specifically, shipping with all drivers. So when it comes to deployment, all your drivers are there. You don't have to take time to install this one or that one, or continue to add up different drivers. Hooking up those different devices, the web-based user interface, it is a lot more modern. It is much easier to use. I've come from the OPC world as well. Today's IIoT platforms are much nicer. From the speed to implement, and really the biggest thing that you also get when you're trying to connect the devices is the built-in utilities to help you troubleshoot those connection issues. So if the device doesn't hook up right away for whatever reason, you've got at your fingertips ways to check out if the route exists from the platform to the device, and just kind of help you guide you through resolving any issues. So much nicer from a user friendly and modern approach to getting the job done.
Great, thanks, Mark. Okay, let's next up, let's look at how the two technologies collect data. Mark, I'm sorry, Dave, for OPC server.
Thanks, Allison. So the way OPC servers work are they're basically, after you make your connection and gather the data, you're exposing that data into a standard OPC format. And that allows that normalization or standardization of the data so other systems can then go acquire it. You have very limited data control, meaning that you can't really control how often the data is happening other than polling rate. You can't add any metadata to it. There's really not much you can do other than just grab that piece of data. It's also required, if you want to store any of that data, that requires a third party, an external system, like a database or historian to store that data. Mark? Yeah,
thanks, Dave. So to me, this is one of the areas that the IoT platform, for me, really starts to stand apart. Like, it does collect the data, but what it does when it's collecting it is it's normalizing that data into a JSON message with the metadata already attached, which is super nice, again, to start to work with that data. You don't have to add the metadata yourself. It's built in. You can add custom fields. That's great, but the basics are already there for you. The message broker technology, from a security standpoint, again, it sets itself apart from what you would see with OPC server. You need to subscribe to the different topics or the different pieces of data in the message broker in order to work with them. Again, provides an extra layer of security around how and when people can work with that data. So it's not just out there for anybody to use. And the built-in time series database is super nice. All the data that comes into the platform is automatically stored into that time series database. That allows you to do a lot of edge processing just out of the box. You don't have to write queries to put data into this database. It just inherently occurs. Again, those little features start to really build on that modern concept of how do you use the data as effectively, as efficiently, and as quickly as possible. The IoT platform really starts to shine just with those extra pieces from a data collection standpoint.
Okay, great. Thanks for that explanation. All right, let's get even a little bit deeper into the data acquisition piece with how OPC Server exposes data. Dave?
Thank you, Allison. So traditionally, for the last 30 years, OPC servers have exposed the data using OPC DA. There's a couple other options as well from HDA or alarming and that kind of stuff. But traditionally, data acquisition is the how it's exposing data to other systems like SCADA or historians. So it's been very limited in how it's exposing data. Back in 2008, when the OPC UA format came out, that was added to OPC servers to expose the data as OPC UA. So that's traditionally it's OPC DA, and recently OPC UA has been exposing that. We still have limited data control, meaning there's not a lot you can do with the data other than exposing just that tag value and very limited metadata around that. And then from the standpoint of trying to keep up with the changing technologies, there's been some limited integrations that have been built in, some plugins that have been added to try to expose data as more modern technologies like an MQTT server or MQTT protocol or a REST API call. Again, it'll expose it but it's very limited in what you can do with the customization on that. And again, if you don't have that external system to store that data, you lose that data if you lose that connection to the system. So that's gone unless you have that historian or database external to the system. Mark?
Yeah, thanks, Dave. So again, similar to the OPC server, the IIOT platform, it can publish data using OPC UA, but then it also starts to add in a lot of other more modern type protocols, MQTT, Kafka, and such. What gets really nice though too is you get that precise control over how and when the data is published. So there's pre-built integrations that you can use to send data to Azure and Amazon, but the control you get is you don't have to just send everything up. You can use in the built-in features to do change of value, so you're only sending up values when they change. You can pre-calculate, so you can do the calculations at the edge and only send up the results, which again helps you on your data ingestion costs in the cloud, which can get a bit high. And what's also there is the store and forward capability. So if you lose the connection to Azure or AWS or Google, you don't lose the data. It's buffered on the platform with a store and forward capability. So once the connection is reestablished, that data will start to be sent again and received in the cloud. So again, there's a similar features, but again, they're more extensive on the IoT platform compared to the OPC server.
Great, thanks, Mark. So this is kind of where the two technologies really diverge, and we're going to talk about some of the edge computing functions. First, let's talk about analyzing data, and Dave, how OPC servers can help with that.
Thanks, Allison, making it easy on me. But OPC servers are designed for data acquisition and standardizing that data format. So there's no analytics built into an OPC server. That's done by third-party applications. Mark?
Yeah, thanks, Dave. So on the IoT platform that we talked about before, with that built-in time series database, that really starts to allow you to do a lot of this edge processing and analyzing the data. So you can create your custom dashboards and data flows using the data that's coming in or the data that you've already stored in that time series database. On top of that, you can do additional data visualization if you want to run third-party applications on the edge platform itself. You get access to a library of pre-built KPIs such as OEE, production count, moving average. So again, it's a low code environment to get you started and going, so that you can really start to work with that data. On top of that, the data model concept, where you can start to create data models. So within that model, you might have data elements and metadata, but you might have calculations that are performed automatically. So by organizing your data into those data models, you can kind of encapsulate what you want to send up to the cloud or to another system in more of a digital twin type format, which again really starts to extend how you work and analyze with the data. Again, it's all out of the box on the platform. So you can do some of these things with OPC Server, but you're going to have to cobble it and integrate the surrounding systems into your server, whereas the platform is designed to just help you do that as effectively as possible.
Okay, thank you. So let's talk a little bit about applications and how the two technologies handle that side of the fence. Dave, for OPC Server.
Thanks, Allison. So again, OPC Server was designed strictly for data acquisition. So to send data it's sending data to applications. It's not running any applications on it. It's exposing the data for another application to use. Mark?
Yeah, thanks, Dave. So on the IIoT platform, you can write, manage, and orchestrate your applications, and best of all, expose the data back from that message broker we talked about earlier. You can run that data directly into your applications. So again, it's seamless. You can run your applications, write them with whatever language you want. So Python or C++ or anything you need, as long as you can compile it as a container, you can run it on the IIoT platform. So really, the customization and the commonization of what types of applications you want to run, being able to run them on the IIoT platform and manage them, so the same applications are running across different lines, across different sites, really starts to bring the power of the platform into your manufacturing facilities.
Thanks, Mark. And really along the same vein, but we'll talk a little more detail about running machine learning models. Dave?
Sure. Again, data acquisition only. The OPC server is going to expose that data that can then be used to ingest data into machine learning models, and depending on the format you want, and maybe you have to write some middleware to expose that data. Mark?
Yeah, thanks, Dave. So with the machine learning models, this is where you can sort of really start to get into the integration with your IT systems, right? So you can run your machine learning systems with the data stored in your time series database. You can feed it with other data that you're acquiring from different systems. Those models will run at the edge, but you can also then do additional crunching in the cloud, determine the results of how your models are working, and then in real time feed that information back into your models to continually drive their improvement. So it's that experimentation mode that you can really start to get with the IoT platform, again, because it's all hooked together. It's not different pieces that you have to cobble together and manage. The IoT platform really helps you get your arms around the whole closed loop process, and it really drives that machine learning operations cycle. So again, quite a nice feature compared to, again, having to do it outside of a system.
Thanks, Mark. And again, those were really the edge computing features. So let's go to management, which is really a critical piece for any of these technologies, and talk about how they handle security and deployment and management from a central location. So Dave, let's start with OPC Server on that front.
Sure. Thanks, Allison. So again, OPC Server is doing the data acquisition. It is required to run on a Windows, which, as we all know, Windows requires frequent updates and patches that could always disrupt data collection. Again, has to be installed on a Windows server. There's all sorts of other security issues that are coming along with that. And then each instance must be managed individually. And what I mean by that is, yeah, you can manage them remotely, but for instance, if you want to update the software, you're either having to remote into a server or go to the server and actually update that. And yes, some of those can be automated. There's platforms out there, but that's another system that you have to develop and manage to make that a little bit easier. But it's really, to manage a OPC server because of the Windows, it's something that you have to do basically one at a time. Mark?
Yes, exactly, Dave. I think with the IoT platform, what our customers are liking is, again, that remote management piece and the centralized management for any number of sites. So you don't have to touch each individual instance. You can push out updates. You can push out new applications. You can push out the templates and the common artifacts that you want to deploy. That really lends itself to being flexible and scalable within the enterprise. A couple other pieces that the IoT platform really gives you is those flexible deployment options. So OPC server, it runs on Windows, and there you go. With the IoT platform, you can run it as a whole OS on a physical gateway. You can run it as a virtual machine. You can even run it now as a Docker container within your environment, and it runs as a secure Linux-based OS. And what we mean by that is it's a trimmed down version of Linux, where only the features that are needed to run the software are present in the kernel. And what that gives you is a more secure, more hardened operating system, which is much much less prone to attacks and vulnerabilities. So from again, the modern new age way of doing the data collection, doing the whole management, the IoT platform really starts to kind of show how much more efficient it can be.
Okay, thanks guys. Really good point by point comparison, I think, of these two technologies. So let's talk a little bit about why you would use an IoT platform for data acquisition. Mark, walk us through through that piece first, and then it's just kind of a summary of IoT for data acquisition, and then we'll talk about the expanded capabilities.
Yeah, sure. Thanks, Allison. So first and foremost, we have to remember that an IIoT platform is a data acquisition platform first. Right out of the box, that's what it does best. It collects your data from different devices on the shop floor. And what it really is we see it as the modern replacement to legacy OPC servers. And what we mean by that is everybody needs to collect data. We all know that, and everybody needs to work with that data. But what you want to be able to do is start to work with that data as fast and as efficiently as possible. And when you start with an IoT platform, you can set the right foundation for your data-driven manufacturing that you need today and in the future. And on this slide, you'll see you get to collect data. Then you can share the data, but you can also manage at scale. So even at the very basic piece for data acquisition, the IoT platform starts to already set itself apart. And we'll get into a bit more of that on the next slide, where it really starts to shine. So here you can see the dark green pieces. Really, that's where you're going to start to grow and expand and evolve what you're doing with that data. So you're going to start to analyze that data. You may not do that day one, right? Day one, you may just be able to try to get the data, share the data, and manage your deployments. But we all know it's coming, right? Maybe today, maybe tomorrow, but by having the IoT platform, you're ready for whatever the business needs are going to be. So you can analyze that data, you can run the applications, you can do your machine learning models. So you expand on the definition of data acquisition. So that 30 years ago meant something a lot different than it does now. And our customers that we see are using IoT platforms in the same standard way to start with, but they are looking forward to growing. They're trying to expand. They're being innovative with how that data is, and they want the flexibility. So they're really looking for the right foundation to grow and expand their use cases while being as flexible as possible. That's what really starts to to really separate the IoT platform from your OPC server.
All right, thanks. And at Litmus, we talked to customers that are in a couple different camps. So some already have an OPC server on the factory floor and they're looking at switching. Some are deciding which technology to adopt for data acquisition in the first place and choosing one or the other. But Dave and Mark, can you both walk us through why are customers switching from OPC server technology to IIoT platforms? And we'll start with you, Dave.
Thanks, Allison. So if I look at number one, OPC servers are built on Windows and management is cumbersome, right? So we all know that Windows can be a bit of an issue to deal with. But we're seeing that people are actually switching because of that being so difficult to manage, that they're actually saving time by using an IoT platform to connect to their data and expose that data. Aside from just the stuff about all that Mark has talked about with the analysis and the machine learning and all that. So, I mean, we've actually worked with customers that have just purchased our system because they justified the cost of replacing their OPC servers because they had so many servers and their IT group was spending so much time monthly to doing Windows patches and updates and those kinds of things that it became too expensive for them to do that. So they actually made the switch just on that aspect.
Yeah, Dave, that's a great point. We see that now with our current customer base where they don't have to reboot the server on a regular basis, right? The IoT platform will run. It requires limited hands-on management to begin with, and it just doesn't disrupt your production environment on a weekly or monthly basis.
Great. Thanks. Number two, showing their age, both in user experience and functionality, that first generation data acquisition. You know, in 1990, when the OPC technology came out, you know, it was really an amazing technology back then because we were able to now get data out of the PLCs and into SCADA systems and do that much more efficiently and easily. But it really hasn't changed much from then. The user interface is still kind of old, it's still kind of, you know, wizard walkthroughs and those kinds of things. And it's just a different type of way, you know, an older way of doing that. And that's a common theme